JoJo's Bizarre Adventure, written by Hirohiko Araki, often shows clever application of mathematical concepts in its abilities and fights. One such fight is the final climax battle against Yoshikage Kira in Part 4. Kira tries to estimate the distance between him and Josuke by comparing the ratio of length of his hand and arm to ratio of Josuke's height and distance between them. Using this, he calculates the distance between them to be 13 meters. Quite bizarre. Applications of trigonometry are all around us, from GPS to calculating distances to other planets. But it hasn't always been used such. In this video, let's take a dive through history and see how trigonometry evolved to its current form. Let's go towards the ancient civilizations of Egypt and Babylon. Astronomy has just begun to develop and trigonometry is still not known much, mostly integrated with astronomical calculations. From the ruins of ancient Babylon, a cuneiform tablet named Plimpton 322 has been unearthed. It has been speculated to be an early secant table, but some groups also argue that it could be a list of Pythagorean triplets. Similarly, from the ruins of ancient Egypt, historians have unearthed the Rhine mathematical papyrus, written by Ahmes, an Egyptian mathematician. This text is confirmed to be the earliest written trigonometric problem found till date. It states that if a pyramid is 250 cubits high and the side of its base is 360 cubits long, what is its second? By studying and deciphering the other mathematical texts of this time, we can see that a second of the pyramid would be the ratio of half of the base to the height of the pyramid. Thus, in modern notation, a second would be the cotangent of the angle opposite to the height of the pyramid. Now, let's go north towards Greece during the Hellenistic era, where a lot of the mathematical progress took place. The Hellenistics would make use of the chord of a circle to carry out calculations. Let's find out how they use this to create a sine table. We first draw a circle of diameter d, then a chord is drawn on the circle. Then we denote the angle subtended by the chord by theta. So a chord length in modern notation will be the product of the diameter and the sine of half of the angle theta. From here, Ptolemy created a table of chords which contained the values of sine from half degree to 180 degrees with increments of half degrees. We see the evidences of many basic trigonometric laws and theorems in Euclid's book Elements. Proposition 12 outlines the law of cosines for obtuse angles, and Proposition 13 outlines the law for acute angles. In Hellenistic Greece, we also find the father of trigonometry, Hipparchus of Nicaea. He compiled the first known trigonometric table and also brought forward the idea of a complete circle having 360 degrees. From Europe, we move towards Asia and reach medieval India and the Indian subcontinent. Our story here starts with the mathematical text called Siddhantas. The Surya Siddhanta makes the first use of sine, cosine, verse sine, which is actually 1 minus cosine, inverse sine, etc. Aryabhatta in his Aryabhatiya contains tables of values of sine and verse sine from 0 to 90 degrees. He also coined the terms Jaya or Jiva, Kojaya, Utkramjaya, and Otkramjaya, which became sine, cosine, verse sine, and inverse sine. How does the word Jaya become sine? Well, this all happened due to a mistranslation over hundreds of years and through multiple civilizations. When Indian mathematical texts reached Western Asia, Jaya got translated to Jiba in Arabic. Since Arabic writers would omit vowels, it was written as Jub. This Jub then got mistranslated for Jaib, which in Arabic stands for bosom. Then, when these got retranslated from Arabic to Latin, the Europeans just called it sinus, which was the Latin word for bosom. The sinus slowly got turned to sine, and thus we got our modern notation. And so, the sign we actually use is a mistranslation of half chord into bosom over multiple centuries. In ancient India, we also come across Madhva, who gave the first infinite series for sin x, cos x, and arctan x. Here is a romanized version of the original shlok about the expansion of sin x. Let's see how the shlok describes the expansion of sin x. For any angle theta, let's consider a circle of radius r, and that the angle theta is subtending a semi-arc of the length s. So the length s becomes r theta. For our series, the numerator becomes s raised to power 2n minus 1, which in the shlok is described as s multiplied by n minus 1 s squares. Now each numerator is divided by a denominator such as this, which when simplified simply becomes s raised to power 2n minus 1 divided by 2n minus 1 factorial, which is then multiplied by r raised to power 2n minus 2. When we substitute s is equal to r theta, we get r raised to power 2n minus 1, theta raised to power 2n minus 1, 2n minus 1 factorial, and r raised to power 2n minus 2. Now we simplify the power of r, and our nth terms becomes multiplied by theta raised to power 2n minus 1 divided by 2n minus 1 factorial. Now in the series, if our n is odd, the nth term is added to the series, and if n is even, nth term is subtracted from the series. So according to the shlok, Jia becomes r theta minus r multiplied by theta cube divided by 3 factorial plus r times theta raised to power 5 divided by 5 factorial, and so on. Now since Jia is equal to r sine theta, we get this equation on simplifying. Deleting r from both sides, we get sine theta is equal to theta minus theta cube by 3 factorial, and so on. This becomes our modern Taylor expansion of the series. During development of trigonometry in India, Aryabhata's table of sine reached China and was translated by Kaiyuan Tianjing during Tang Dynasty. But early trigonometry was not widely appreciated, and imperial Shongsha was used. Trigonometry in China started to advance with the onset of Song Dynasty. Polymath Chinese mathematician Shen Kuo was the first to use trigonometry to solve problems of chords and arcs. He worked on a circle of diameter d to calculate the length of a circular arc S, subtended by the chord C. The V in this equation is called the sagitta of the arc, which is the distance between the midpoint of the chord and the arc. Shen's work became the basis of spherical trigonometry and was developed by mathematician and astronomer Guo Shongjing. China also had multiple silk routes that traveled throughout India, Tibet, and Mongolia into the rest of Asia and Europe, and so our story reaches Arabia and Persia. This marked the beginning of study of spherical and plane triangles with the sides and angles. In 9th century CE, we see the trigonometric tables emerge. Muhammad ibn Musa al-Khwarizmi produced the accurate sine and cosine tables, while Hawash al-Hasib al-Marwazi produced tangent and cotangent tables. The secant and cosecant tables were produced by Muhammad ibn Zawir al-Harani al-Batani. At this time, we finally see the separation of trigonometry from astronomy and into an independent field of study. In 13th century, Nasir al-Din al-Tusi wrote the Treatise on Quadrilateral, which contained many trigonometric formulas and tables. He also formulated the plane and spherical laws of sine. For his contribution, he is known as the master of trigonometry. And we reach the age of enlightenment and modern mathematics. With the age of enlightenment begins the modern development of maths and physics. Georges-Jacques Rheticus was the first to define the six trigonometric functions in terms of right triangles instead of circles. Euler formulated the Euler formula of complex numbers, where e raised to power ix is equal to cos x plus I sin x. In 1707, Moivre put forward his theorem where cos x plus I sin x raised to power n can be interpreted as cos nx plus I sin nx. The modern day expansions for trigonometric expressions were given by Brooke-Taylor. These are called the Taylor series. In the 19th century, Joseph Fourier discovered the Fourier series during his attempts to find the solutions to the heat equation, paving the way for Fourier and harmonic analysis. Today, innovation in trigonometry is mostly on integration into our technologies, as its core principles have been largely established. The modern navigation and GPS system apply trigonometry to triangulate your position. Now we've reached the modern day state of trigonometry. And now you can say all the maths you studied in school was for no use. Thank you.